A constant torque of 10 meter Newton is applied to the rim of 10 kg uniform disk of radius 0.20 meter. What is the angular speed of the disk about an axis through its center after it rotates 2.0 revolutions from rest? Okay, so to solve this problem, the first step is to find a relevant concept. So relevant concept, then write down the given information and find a target variable. Okay, target variable. So these are the three things you must do first. Okay, so what is the relevant concept? If you read this problem, a constant torque is given applied to the rim of a 10 kg uniform disk of radius this much. What is the angular speed about an axis through its center after it rotates this much revolution from rest? So there is the angular kinetic energy. So we need some relationship between work and energy, which is work energy theorem. Okay, so a relevant concept in this case is work energy theorem for angular case. Okay, angular. We also have work energy theorem for linear motion that we already studied in previous chapters, but in this case we will need work energy theorem for angular motion. Okay, so this is the relevant concept. So tau is given, tau is 10, how much is that, 10 meter Newton, and then mass is given. I can write down, represent it by, it is also 10 kg. Yes, that's 10 kg. And radius is given, radius is about 0.20 meter, and then theta is given, which is 2 revolution. So to make it easy, let me convert this revolution into radian, because in SI system we measure angle in radian. So if we multiply this one by 2 pi radian divided by revolution, this will be cancelled, and this will be about 4 pi radian. So theta is 4 pi radian. Okay, 4 pi radian, because one revolution means 2 pi radian. Okay, remember this fact, because if to go around, this is 360 degree, this means a 2 pi in radian. Okay, to go around this one. So one revolution means starting from here and completed one revolution, right? 360, and in radian 360 degree is 2 pi. Okay, one revolution. This is meaning of one revolution. Okay, so these are all given things in the problem. So whatever is given, we have to put into right format. I mean, with right representation of the variables. Okay, and now let us find a target variable. In this case, in this problem, what is asked is what is the angular speed of the disk. So target variable is, of course, omega is equal to what, right? So this is the target variable. So what is this? This is target variable. This is our target. Okay, so step 2 is writing down equations. Write equations. Okay, so which formula can we use? So let me write down the work. So work is equal to tau theta, right? in the linear motion, we know work is equal to force into distance, right? Force is equivalent to torque in the angular case, and distance is measured in angular distance, angular displacement, which is theta. Okay, so we will write down work done is equal to tau theta. What is tau? Tau is torque, which is equivalent to force in the linear motion. Okay, so this is the one formula, and also we know W, this is also W. Okay, remember the W and omega looks similar, but omega is like this and W is like this. Okay, remember the difference. And work energy theorem in kinetic angular motion is half I omega square minus half I omega naught square. This is the work energy theorem. This is final angular kinetic energy, and this is initial angular kinetic energy. Okay, so in this case, the initial kinetic energy is 0. Why? Look at here, revolutions from rest. Initially, this disk, which is uniform disk, is at rest, and it rotates two revolutions from the rest. It means initial angular velocity, angular speed is 0. Okay, so this is self known because rest is, the word rest is there. So I can write down W is equal to half I omega square minus half I 0 square. This means this term will be 0, and I can write down like W is equal to half I omega squared, right? This is the word. Now I can replace this W by this tau theta, which is tau theta is equal to 1 by 2 I omega squared. Okay, again I know I, what is I here? I is moment of inertia. Okay, moment of what? Inertia. Okay, so I, this is a disk, so for the disk the moment of inertia is 1/2 mr square. Okay, let me put this information also. If I insert this value over here, what I get? Tau theta is equal to something like 1 by 2 mr square omega square, right? Let me simplify this one. 1/2 and 1/2 gives you 1/4, and then mr square omega square, isn't it? We arrived here. Okay, so after this is tau theta. Okay, so this tau theta will go here to have 4 tau theta, which is equal to mr square omega square. Okay, again simplifying, omega square is equal to 4 tau theta divided by mr square. Okay, so if you remove square here, the square root will be there on the other side of the equation, and then you will get 4 pi theta divided by mr squared. Okay, so this is the case. Now third step is step 3 is do math. Wow, it's easy step, right? So setting up and finding the relevant concept, target variable is most difficult part when solving physics problems. So this is the easiest step. You just have to omega, which is angular speed, is equal to, let me write down all the This is tau. I'm sorry, here I make some mistake. There is tau, and the value of tau is 10 meter Newton, right? And then multiplied by theta. Theta we already get 4 pi rad, and divided by how much is cm? It was 10 kilogram. We got it from question, and radius is also given 20 meter whole square. Okay, so if we simplify this one, we will get omega is equal to 35. Let me calculate this one. Let me put into calculator and get actual value. 4 multiplied by 10 multiplied by 4 into 5 divided by 10, 0.20 squared divided gives you this much, and then square root 35.4. Okay, so let me get the unit. So the unit right here is so what is Newton? Kg meter per second square into rad. Okay, then divide it divide it gives you kg meter square, right? Meter square will be cancelled. Well, the meter square kg will be cancelled with here. It should be, and it should be squared here. Okay, so squared here, and this is the rad divided by second, right? So our unit here is rad per second. So we have angular velocity, angular speed, omega is equal to 34.4 radian per second. Okay, so this is your answer.